Okay, here is some more on the product rule. Okay, so we have two nice graphs if you notice. Here's a graph we're calling F, and here's a graph we're calling G. Right, it has some asymptotic behavior here. It has some different limits from the left and from the right. It has some values that are undefined, but we'll talk about that if we need to talk about it. Okay, but here are your functions. Okay, we have a function we're calling P, which is the product of your F and your G functions, right? So that's the Y value of F times the Y value of G. That's how we get the P function. And then R is done by squaring your X term, whatever X you want to pick, and then multiplying that by the Y value from G. Okay, so you could actually plot these if you wanted to and see what their what their curves look like. I have no idea, and it doesn't really matter for us in this application because we want to do some things down here with our problem, starting with finding G prime at -4. No, it says G prime at -4 equals 2, right? That means the slope of the tangent line at x equals 4, right, is 2. Derivative means slope. What is the value of P prime at 4? So here's our question. That's what we're going to find first, the value of P prime at 4. So remember, when we're finding a P prime, we're finding the slope of the line at the points x equals -4. Okay, so let's go back and see what is our P equation. I believe P was F times X, or F times G, sorry. F of X times G of X. That is our P equation that you got from the top. So how do we take the derivative of a product of two functions? We use the product rule. So we start with P prime of X, right? P prime means we're taking a derivative. And your product rule says that first we take the derivative of the first thing, so F prime, multiply it by the second, plus the normal first multiplied by the derivative of the second. Okay, so this is a straight up product rule formula. Right, we have two functions, F and G. The product rule says you take the derivative of one times the other, and then take the one times the derivative of the other. And we want to evaluate this when x equals 4. So we're trying to find what is P prime at 4. So we're going to change all of our x's into 4's. So it's muy importante to understand, when we're taking an F prime, we're looking for the slope of the line when x equals -4. And when we're taking G of 4, that's the Y value from your graph when x is 4. So a Y value versus a slope. So let's first go up and we'll find the slope from F when x is -4. Okay, so here's an x value of -4. What's the slope of this line? -1. The slope of the line from our F function at -4 is -1. So I'm going to replace F prime of -4 with -1. Okay, and now we come over here to our G function. And what is the Y value from G when x is -4? 1, 2, 3, 4, 5, 6. Is this 6 right here? So the Y value is going to be 6. So we're getting our answers, we're getting our numbers from our graphs. So F of -4 is what is the Y value at -4. It happens to also be -1. And then what is the slope of G at -4? Well, this one, we actually come back to our original problem. It says the slope of G at -4 is +2. Okay, so this one we don't get from our graph. We're given that information in the problem. Okay, so this is P prime of 4. This is the slope of our line at -4. Negative 6 minus 2 is negative 8. Okay, there we go. So that's the slope of our line, the tangent line at negative 4. So let's finish the problem, which says, find the equation of the tangent line to the graph of p of x when x equals negative 4. Okay, so anytime we're writing an equation of a tangent line, we need to know two things. We need to know the slope, and we need to know the points. Okay, we need to know the slope, and we need to know the points. Well, what we just found is the what? That's the slope, right? So we know the x is negative 4. So what's one thing that we have to find is the y value, right? We need to know the y value. So that means we're going to go back into here. This is where our y value comes from your original function. So we're going to find what is f at negative 4 times g at negative 4. So I believe f at negative 4 was negative 1, and g at negative 4 was positive 6. So that means our y value is going to be negative 6. Okay, so every time we're writing an equation of a tangent line, we need to know the slope at that x value, which is the derivative evaluated at the point, and we need to know the y value. So now that we know both of these things, we can write the equation in point slope form. So remember, it's always y minus the y term. And since our y term is negative, minus a minus becomes a plus. Okay, equals m times x minus your x term. And since our x is negative, minus a minus becomes a plus. Very nice. Okay, let's jump over here and do this other example. So now we're looking at r. Remember, r was x squared times g of x. That's our r function. We're told that if r of negative 2 is 20, so the slope, right, the slope at negative 2 of our r function is 20, what's the value of g prime of 2? All right, so that means once again we have to take the derivative of r. So we know that r is x squared times g of x. So let's take the derivative. R prime of x equals. What is the derivative of x squared? 2x. Times our normal g function left alone. Plus our x squared function left alone, right? So we take the function as it is, and then we multiply it by g prime, right? The derivative of your second function. So now let's get to evaluating what is r prime of negative 2, right? So that's 2 times negative 2. We're going to replace x with negative 2 everywhere we see it, times g of negative 2 plus negative 2 squared times g prime at negative 2. Okay, so let's do some simplifying in here. I know that r prime at negative 2 is 20. So 20 goes here. 2 times negative 2 is negative 4. And what is our y value from our g graph when x is negative 2? Okay, that's negative 3. Plus, negative 2 squared is 4. And we don't know what g prime at negative 2 is, right? That's what we're trying to solve in the question. What is g prime at negative 2? So this is now an algebra problem. 20 equals 12 plus 4 g prime at negative 2. So that's our variable, right? G prime at negative 2 is what we're trying to isolate. So let's minus the 12 from both sides. 20 minus 12 is 8 equals 4 times our problem. So what does g prime at negative 2 equals when we divide both sides by 4? 2. So the derivative, the slope of our tangent line to our g graph at negative 2 is positive 2. So now let's do the second part of our question, which says tangent line to the graph of r when x equals negative 2. Okay, so we know the x value is negative 2. We're told that the slope up here is 20. So we just need to find the y value. So we're going to plug -2 into our r equation. Okay, so that's -2 squared times g at -2. Okay, so -2 squared is +4. G at -2 was -3. So we have a y value of -12. A y value of -12. So let's write our equation. Y minus 12 is a plus, equals our slope was 20, right? That was r prime at -2 is 20, times x minus a minus, once again, is a plus, and that is the equation of our tangent line. Sorry, my recording device isn't very clear anymore, but this says estimate f prime at 3.5. Okay, estimates f prime at 3.5, right? So we're looking for the slope of the line. So if we know some points, we're going to go back to our Algebra 1 days and know that f prime is y2 minus y1 over x2 minus x1, right? Because that's our slope formula. That's our slope. Slope and first derivative are the same thing. Okay, so if we're looking for 3.5, well, that's right in between here of 3 and 4. So we have a y value of -2 minus 1, right? So that's this y value minus that y value, y2 minus y1, over 3 minus 4, which is your x2 minus x1. So simplifying, that becomes -3 over -1. So it looks like f prime at 3.5 is approximately +3. Very good. Okay. This one says, okay, so here q, this is a q, is defined as 2 times our f function minus 4 times our g function, right, the y values. And we're asked for what is q prime at 4. So first we need to take the derivative and figure out what q prime is. So the derivative of 2f of x is 2f primes. The derivative of 4g's is 4g primes. The number stays put, and you put a prime on each of your letters. Okay, so now that we know that, we can replace x with +4, because now we want to evaluate, we want to go into our table, and we want to figure out what all of these values are at 4. So f prime at 4, according to our table, where's 4? 4 is the top line. F prime at 4 is 2. G prime at 4 is -3. So now it's just a matter of adding these things together. 4 plus 12 is 16. Okay, let's see what else we have over here that we can't read. So here we have a k function, which is 2f of x plus 3's, right? That's one function, times 3 minus g of x. So when we take k prime, when we find the derivative, we are going to use the product rule. Okay? So first we take the derivative of our first parentheses. What is the derivative of 2f of x plus 3? 2f prime x's. Because the derivative of a constant is 0. It does not have a slope. So the derivative of 2f of x plus 3 is 2f prime of x. And we multiply it by the second thing left alone. Plus the first thing, 2f of x plus 3, times the derivative of this guy. So 3 minus g of x. What's the derivative of 3? 0, right? So 0. And then we have a negative g prime of x. The negative stays there, and we turn g into g prime. So anytime we have a constant, inside of our parentheses, the derivative of the constant is 0 and is no longer applicable. Okay, so now we want to evaluate it at 3. Evaluate at 3. So change all of our x's to 3's. Okay, now we're going to be very careful in evaluating this. Right? This is 2 times f prime at 3 from your table. Times 3 minus g of 3 from your table. Right? Plus 2 times f of 3 from your table. Plus 3, right? So we're going to put that in there. And then times g prime at 3 from your table. So look at the table and get all these values. Okay, those are your values from your table, right? These 4 from your g primes and your f's and your g's and your f prime respectively. So now let's see how our order of operations come in here. So 2 times -4, well that's -8, times 3 minus -3 is +6, plus -4 plus 3 times 2. Okay, which continues. This is -48 plus -1 times 2, which is -2, is -50. Just kidding. So I forgot to bring down the negatives. Thank you, Francisco, for that. So this should be -48 plus 2, which looks like it's -46. There we go. That's better.